Welcome back to our non-parametric statistics series. In today's lecture, we will study Kendall's Tau correlation. Although it serves a similar purpose to Spearman correlation, its method of calculation is completely different. Instead of using differences in ranks, Kendall's Tau compares concordant and discordant pairs. By the end of this lecture, you will know when to use Spearman correlation and when to use Kendall's Tau, as Kendall Tau is better choice. In the previous lecture, we learned Spearman rank correlation. A common question is, if Spearman already measures rank correlation, why do we need Kendall's Tau? The answer lies in how these two methods calculate association. Kendall's Tau is often considered a more robust and reliable measure, especially for small sample sizes and data sets containing many tied observations. Kendall's Tau is especially useful when your variables are measured on an ordinal scale or when observations naturally have ranks. It is performed over Spearman in many research studies because it provides a more conservative estimate of correlation and handles tied ranks more effectively. Suppose we want to know whether interview rankings are associated with actual job performance. Both variables are expressed as ranks. Therefore, Kendall's Tau is an appropriate method for measuring their relationship. The first step is to list all possible pairs of observations. If there are 5 observations, there are 10 unique pairs. Each pair will be examined to determine whether it is concordant or discordant. A pair is called concordant when ordering of the two variables is the same. If one observation ranks higher than the other in both variables, the pair is concordant. These pairs increase the value of Kendall's Tau. A pair is discordant when the ordering is reversed. In one variable, one observation ranks higher, in the second variable it ranks lower. Discordant pairs reduce the value of Kendall's Tau. After examining every possible pair, we count the number of concordant and discordant pairs. These counts form the basis of Kendall's Tau calculation. This is the Kendall's Tau formula. Tau is equal to C minus D upon N into N minus 1 upon 2. The coefficient ranges between -1 and +1. Values close to +1 indicate strong positive association and values close to -1 indicate strong negative association. Interpretation is straightforward. A positive Tau indicates that higher ranks in one variable are associated with higher ranks in the other. A negative Tau indicates an inverse relationship. Comparison is one of the most important parts of today's lecture. Spearman uses rank differences. Kendall uses concordant and discordant pairs. For small samples and data sets containing many tied observations, Kendall's Tau is generally preferred. Now let us perform Kendall's Tau in SPSS. Navigate to Analyze, then Correlate, then Bivariate. Select Kendall's Tau B and run the analysis.
I have already started SPSS and there are 5 students A, B, C, D, E. Their interview ranks are 1, 2, 3, 4, 5. However, their performance ranks are 2, 1, 3, 4, 5, 4. We will go to Analyze, Correlate, Bivariate, and we will select both the variables interview rank and performance rank. There is no need to change any options and bootstraps. We will select Kendall's Tau T and we will tell flag significant correlations with the two-tailed. We'll say OK, and the output is our Kendall's Tau is 0.60, that is the correlation, and the p-value is 0.142. It is more than 0.05. So we can say there is a positive correlation, but that correlation is not statistically significant.
SPSS output provides two important statistics. The Kendall Tau's coefficient measures the strength of association. The p-value tells us whether the observed relationship is statistically significant. Python provides the Kendall Tau function in SciPy. This function directly calculates both the Tau coefficients and its significance level.
I have already started Jupyter. I like this editor. You may use any other editor. There is no issue. I have already written the commands. From SciPy.stats import Kendall Tau. Variables x is equal to within square brackets 1, 2, 3, 4, 5. Y is equal to within square brackets 2, 1, 3, 5, 4 as we used in SPSS. So Tau comma P, this can be anything, is equal to Kendall Tau x comma y. Print Tau is equal to Tau and print P value is equal to P. So because it will take some time to import Kendall Tau, when we run it, it will take some time. Our Tau is 0.6 as we got it in SPSS, but the p-value is 0.233. I want to round it up. I can round up to 3 decimals. Around comma p 2 or 3 and we close the bracket. So let us run it again. Run. So now p-value is 0.233. So these minor adjustments you can know. If you want to learn more from the very beginning, just start my video, Python video part 1. And from then part 1, part 2, part 3, there are 30 videos which you can usually watch. But now here in this case, in our SPSS, it was 0.142, but in Tau it is 0.233. We will discuss it.
Please notice that SPSS and Python produce the same Kendall Tau coefficient, but the p-values are slightly different. This happens because Python computes the exact p-value for small samples without ties, whereas SPSS generally reports the asymptomatic p-value. Although the numerical values differ, both lead to the same statistical conclusion. The Kendall Tau revealed an insignificant positive association between interview rank and job performance. Tau is equal to 0.60 and P is greater than 0.05. This is the standard format for reporting Kendall Tau in a thesis, dissertation, or journal article. Always report both the Tau coefficient and p-value. Let us summarize today's lecture. Kendall Tau is non-parametric measure of association. It works well with ordinal data, small samples, and datasets containing tied ranks. Although Spearman and Kendall's measure similar concepts, Kendall often provides a more reliable estimate when ties are common. Thank you. Thank you for watching. Please subscribe, like, share, and comment. In the next lecture, we will begin another major topic in non-parametric statistics, chi-square test of independence. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.